our answer on these. It's really just getting that particular variable by itself. So how would we do the first one? So we get I over PR equals T. And you guys know we can flip that and say T equals I over PR. Either way is fine. All right, what about B? It's a little more tricky. Yeah.
You add the P to the other side and subtract PRT from A.
I like the adding this over. So if we subtract the PRT, we have a P by itself, but we still have a P in the answer. Right. So they're the same variable, just different terms. So if I can't actually combine them because they're not like terms, can you think of anything else I could do with that P?
You can divide it, right?
Right track. So before we divide it, we need to factor it out. Do you guys remember factoring things? Yeah, this one's kind of a stretch. Both of these terms have a P, so we could pull it out. And what would that leave if we take it out? Plus 1. So now we have P times something. So to get P by itself, we divide. Solve for x on that one for me. That's more like your equation. Solving for x is what you're used to. So what are your thoughts?
I distributed.
Alright, we're trying to solve for x. So we can see we have x's in 2 places, so we need to get those on the same side. So if I subtract over my 4x, and then do I want this 15a and 4b? No, so we're going to move those over. So we are going to add over the 15a, subtract over the 4b. And you could have those written in a different order, just as long as the 2 and the 4 are negatives. And then final step. Did anybody write it differently if you went ahead and divided, like you have -1 plus 15 over 2a minus 2b, add the terms in another order, something equivalent. Is that one okay? Let's do one final problem and then we'll move into. I'm gonna do that one. Let's do this one. So this will be like our example D. Kind of jumping around today. How am I going to solve that for f? Yes, good. So if you have a fraction, easy way to move it to the other side is to multiply by the reciprocal, so 9 over 5. Not the only option, but definitely the easiest. And then so you guys seem like you kind of remember how to manipulate equations. That's not a big thing. All right. Then we are going to start section 2. So we'll go ahead and start with what everybody hates and get it over with. We're doing word problems, and they're not as bad as everyone always says they are. You guys get to get it over with the first week, and then we can move on. I did all of the examples that I'm going to work. I do have a handout posted in Classroom where I just typed up my examples and shared them there. So if you don't want to copy down the entire problem, you could just make a note in your notebook that it's posted on Classroom, so you don't have to copy everything frantically. So when we solve word problems, I'm going to have some pretty specific steps that we're going to go through. We're going to spend probably a couple days at least on this, looking at a couple different scenarios. The ones we'll look at today, you've probably mostly seen things like it before. So this is also on that handout that I posted, so up to you if you want to copy it down or not. But the first thing I do ask is that you identify your variable. I really don't want to see you trying to solve equations and using x's and y's, and I don't know what you're talking about. So on every problem, I'll give you a point just for identifying your variable. So whether you say x is blah, or you draw a picture and you label it, something to tell me what your variable is. You must do that. Second, we need to put anything else in terms of the same variable. At this point, I know in Algebra 2 you got to the point where you were solving systems of equations, but we're not doing that right now, so we want to see, can we solve this using only one variable at a time, so we don't have to set up an entire system. So only one variable. If you have multiple things you don't know, we need to put it all in terms of the same variable. Step 3, setting up a model. That's like you're writing an equation so that we can solve these. Step 4, we solve it, check our answer, make sure it's reasonable. And I really should probably add step 5. I want you to answer in a sentence. My rule of thumb is if I give you a problem in words, I want you to answer it in words. Especially when we have multiple things we don't know. You can't just say x is 5 at the end. You need to tell me, what did you actually find? Did you answer the question that you were asked? All right. Ready to try one? So if you don't want to copy this whole thing down, like I said, you can just say example 1, and that is posted on Classroom. So this is what I see when I give them a word problem. If the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. Find the dimensions of the original square. So they read the whole thing like that and say, I don't know what to do. And of course you don't, because I don't know what I just read. That didn't make any sense. So we have to slow down. So if the length of each side of a square, stop. What could I do? Draw a square. Is increased by 3 centimeters. So what just happened to my square? So now I'm going to draw a bigger square. Pretend my squares are, I'm out of practice writing on my slate after the summer. Alright, so this was my old square. Here's my new one. Okay, do I know how big my old square was? No. So what could I do? What could I label? Pick a variable. It's a square, so we know all the sides are the same. Alright, my new square. I don't want to call it y. I told you keep everything in terms of one variable. What would my side length be?
X was 3.
Right, it was increased, so that means we added. So even if everything else in your problem is wrong, you get the point just for doing that. Okay, now let's keep reading. The perimeter. What is perimeter? The perimeter of the new square. So my new square, my perimeter, so we could go through and write x plus 3 plus x plus 3. How many times do we have to do that? 4. What's the faster way of doing this? Yep. But it doesn't matter, whichever way your mind works. So the perimeter of the new is, in a word problem, what does is mean? 40 centimeters more than. What does that tell me to do? Twice the length of each side of the original. Now solve that equation. What'd you guys get? So, am I done? No. Now we have to answer the question. So the question was to find the dimensions of the original square. So in my sentence, I'm going to say the original square had sides 14 centimeters long. That wasn't too painful, was it? Okay. Let's try another one. A rental car company charges $20 per day and 30 cents per mile for renting a car. Janice rents a car for 3 days and her bill comes to $72. How many miles did she drive? Is this one where it would make sense to draw a picture? No. So you have to tell me in words what your variable stands for. So you can pick whatever letter you like. So if I said x, what is x? What am I trying to find? So I'm just going to say the number of miles. Is there any other unknown in this problem? It only asks me how many miles, so I don't have any other variables that I have to worry about. So step 1, identify the variable, we did that. Step 2, put everything in terms of that same variable, we don't have any others. So now we're just ready to write our equation. So the rental car company charges $20 per day, and she rents it for 3 days. So what would I do? $60, or you could say 20 times 3 if you want to know where that came from. You go ahead and put 60, I don't care. And we also pay 30 cents per mile. So what should we do? Okay. What do we have to do with that? 30x. Okay. Is there something wrong with how I have it written? What's wrong with it? Yep. And the bill is $72, so it equals 72. So now we can solve. If you guys need calculators, you are just welcome to grab one off my phone. guys get 40? So then we just write our sentence. We wanted to know how many miles, but X was the number of miles. Are you ready for a more challenging one? Okay. I'm going to put it up here. I want you guys to read it and see if you can draw a picture of the scenario. Okay, you don't have to try to solve the whole thing yet unless you want to, but see if you can draw a picture to describe this. Do we understand what's going on here? So we have an original sheet of paper, so like my sticky note here, 20 inches wide, 15 inches high. He then places that sheet of paper on a mat so a uniformly wide strip shows all around the picture. So you have your paper and you're putting a mat behind it to kind of frame it. Okay. What does it mean when it says a uniformly wide strip shows?
It's equal wide all around.
Yeah, this distance is the same all the way around. Okay, so I'm going to put a piece behind this. Just have to excuse my artwork. I'll get better at drawing straight lines, but it takes me a while to get back in the habit of using this. Okay, so did I say how much was showing all the way around? So we could call that X. But I know it's uniform, so it's the same in all of these. The perimeter of the mat is the outside piece, is 102. So if I need the dimensions for the outside to add up. So let's think about this. We know, how far is it to get from here to here?
Rated X.
Yeah, remember my 15 is this height right here. So this width is X. How far is it to get from here to here? 20. And then how far is it from here to here? So all together, how long is this?
2x plus 20.
So for the side, how far is it from here to here? X. And then from here to here,
15.
and then from here to here. So all together, that would be
2x plus 15.
So perimeter, we add all four, so we could write them out, or we could realize, okay, these two are the same, so I could do 2 times the 2x plus 20, and 2 times the 2x plus So then how do we solve? Have like terms. We get 8x plus 70. Subtract over 70. You probably already noticed I don't really show every little thing. Is that okay with you guys? Okay. If I fail to write something down that and you don't know where it came from, just tell me. And likewise, I don't care if you guys don't show every single step. Just show me enough to know where you're coming from. So now what? Write a sentence. The question was, how wide is the strip of mat showing around the picture? We were in inches. So it will be 4 inches showing on each side. Are you guys ready for a new type of problem? Kind of done. These are probably similar to problems that you've solved before, like setting up an equation, drawing a picture, those kinds of things. The next type, and I'll probably do one or two today, depending, and we'll probably do some more tomorrow if we need to. I want to talk about mixture problems, and there are different ways to do these problems. I don't want to confuse you by showing you 3 different methods. I'm going to show you my favorite. If you don't like it, tell me and I'll show you another one. Okay? So how much water should be added to 2 gallons of pure antifreeze to obtain a solution that is 70% antifreeze? Right, these problems seem kind of terrifying if you're just looking at them. You've got water and pure antifreeze and trying to get 70% antifreeze, and there's a lot of numbers that can get jumbled together here. I like to organize them in a table. So when I make my tables, my rows are the things that I'm mixing together. So I'm adding water to my pure antifreeze to get my mix. Now, I don't care what you label it. If you want to call it first, second, and total, that's fine. If you want to be water, pure, 70%, that's fine. I do want some kind of label here because this is what I'm going to use to identify my variable. And if you don't have any labels, then I still don't know what your variable is. Now, to calculate this, we are going to need some kind of formula. So let's take a little detour for a second. Let's just think through a scenario. So when my kids were little, they liked drinking apple juice. Okay, but I thought apple juice had too much sugar in it, so I always watered down their juice before I gave to them. So let me ask, if I bought, let's say I had a gallon of juice, and I wanted it to be 50% juice at the end. What would I have to do to it? How do I dilute that?
You just add a gallon more.
Okay. So at the end, if I had 2 gallons of my mixture, how much pure juice was in that? 50%, which was 1 gallon, right? So if you take your 2, the 2 gallons we had, times 0.5, because it was 50%, we get 1 gallon of pure juice. So likewise, if I had 2 gallons and it was 25% juice, how much actual juice was in there? So what would you have to do?
Like half a gallon.
So you would have, yeah, if you if I had 2 gallons after I mixed it, and it was 25% juice, so 2 times 0.25 would give you half a gallon of true juice that I put in there starch. So this is kind of this formula, and we're going to use the amount times the concentration equals the amount pure. And I will use this formula on every mixture problem. So the total amount I have times the concentration will tell me the amount of pure whatever. In this case, we were talking about antifreeze. So if we set this up, now I have a chart, and I need to fill in all these boxes. So I go back to the problem, and I try to figure out where my numbers are going to go. So it starts out, how much water? So what would I put for the amount of water? Yep, because I don't know. Should be added to 2 gallons of pure antifreeze. So where do I put that? To obtain a solution that is 70%, where would that go? Yeah, so it's in my mix, and that is the concentration. Your concentration is like your percent. So just like when you're doing with percents, you know how to write those in decimal form with your decimal back to, so 0.7. All right, I still have a lot of gaps, but we can figure these out. Pure antifreeze. What's your concentration if it's pure? 100%. So I would put a 1. All right, my water. If I go get a bottle of water out of the water fountain, what percent antifreeze is that? 0. I certainly hope so. So my concentration of my water is 0. Final thing, the amount of my mix. So if I pour in X gallons of water and 2 gallons of my pure, how much do I have?
X was 2.
Just adding this together to get our total. So now look at my formula. Amount times concentration. So we're going to multiply these to get my box. So X times 0 is 0. 2 times 1 is 2. And this, I'm going to go ahead and just write it out for a second. That way if you're looking back in your notes, you'll figure out where it came from. So 0.7 times the X plus 2. Alright, the reason I love these charts so much is it organizes a lot of information, but then if you can get to this final column, the equation really writes itself. This is the amount of antifreeze I put in from the first thing. That's the amount I put in for the second thing, and that's my total. So what should I do? We'll have to distribute, and if this is the first and that's the second, we can add those together, and it should equal our total one to set up the equation. And the equation would be 0 plus 2 equals the 0.7 times X plus 2. Subtract over the 1.4. Divide 5.7. decimal, or you just leave it as a fraction. So going back, the question said, how much water? X was the amount of water. So there must be 6/7 of a gallon of water in the mix to dilute it down to 70%. Alright, I know that one was a little bit different. Questions? Did I lose you? Why don't we, let's stop there for today. I'm gonna give you guys a couple to try on your own. I told you that you could use my textbooks when you're in here, so just please don't leave with it. Leave it in here. So let's try. I'm going to go ahead and put one of these mixture problems on here, but I'm going to go ahead and throw the disclaimer. I'm not going to collect this tomorrow. I'm just going to add to it. So if you can't get, number 30 is a mixture. If you get stuck on it, that's okay. We're going to do some more of those tomorrow, but I wanted to give you one in case you wanted to try it and see what you could get. And then we'll just add to it. Books are on that back shelf over there.
Grab the one that I left last time.
That's fine.
Okay.
Huh? And remember, there is answer key in the folder. You can check yourself. Make sure you're defining variables and answering the 7.